Hello and welcome to SQL Bits. I am Kimberly Tripp and I'll be giving two sessions, one today and one tomorrow, which are really part one and part two of a session on troubleshooting query plans. The reason why I have two parts is that I find often query plans are assumed to be statistics problems. When somebody is running a query, they see estimates off from actual and they think, oh, those darn statistics. And they do things like updating statistics when in fact there are better solutions. So I love talking about this. And as you guys know, this session is recorded. So I am online in the chat ready to answer your questions as well. So I absolutely hate listening to myself talk, so I'm sure I'm probably going to mute myself and have no idea what I'm talking about when you ask your question, but I will try. So I'm really looking forward to giving these sessions, and thank you so much for joining me today, and hopefully you'll join me tomorrow as well. I've got 3 monitors and a crazy setup here, so occasionally I'm going to have to look to my left to switch things, but I am going to switch over to the slides now and give you a little bit of background. I have been working with SQL Server for 25 years. Actually, I've been working with SQL Skills for 25 years and SQL Server for 30 years, actually, and still having a good time. So I definitely don't mind your questions. I am also available on email, and I have a blog and Twitter and all that good stuff. And you can read the slide and see some of that background. I really like the technical content a lot more, so I really want to dive right into that. We have 50 minutes. I am not probably going to do a lot of demos in these sessions, but I do have a lot of scripts associated with these sessions. And I will want you to go back and look at those scripts and play with what the scripts are showing you, and possibly look at some of the additional resources that I have, because I think that these are incredibly common problems. I see them pretty much everywhere I go, and what I want you to be able to do is to be able to properly recognize what the problem is and solve it. So I'm really going to start this session with a little bit of root cause analysis, because if you don't end up looking at really what the problem's source is, you're not going to solve the problem correctly. So it's really important to me that you first look at whether or not the problem is in fact a statistics problem, which is often what people think the problem is, or whether or not it's actually a caching problem. So I'm going to give you some ideas and some things to test, and really some things to consider when you are kind of thinking that you have performance problems, and then I'll give you some solutions. So this session is going to be how to determine if in fact it is a caching problem, and if it's a caching problem, then where exactly is that problem and how do you solve it? And if it is in fact a caching problem, it's going to depend mostly on what the statement execution method is. Is it an ad hoc statement? Is it an SP execute SQL statement? Is it exec? Is it a stored procedure? If it's a stored procedure, what is it within that stored procedure? Is it exec? Is it SP execute SQL? There's a lot of confusion here, and I think really understanding how statements execute and how caching works is really the center of understanding all of these types of problems. And if you can get to that kind of understanding, I think you're going to do a lot better off with the way that you interact with SQL Server, and ultimately you get better performance as a result of it. So like I said, we're going to start with some root cause analysis and troubleshooting, and then dive into caching. So as far as the performance problems themselves, what I want you to first think about is, what are the types of problems that you're seeing? Is it, somebody comes to you and says, I had performance problems on Tuesday? Because I have to admit that is incredibly difficult to try to go back and solve. Things like Query Store are incredible for this. But if somebody just comes to me and I am not doing anything to monitor or see what's going on, maybe I haven't enabled Query Store, this just doesn't help me at all. What does that mean that performance was slow on Tuesday? But if somebody is saying, well, over time, this query has gotten slower. Then one of the questions I'm going to be asking is, well, how much time? Is it slow, at 10 o'clock in the morning, but at 2 o'clock in the afternoon, it's fast, but then at 3 o'clock, it's slow again? In other words, does the query performance seem to fall off a cliff? Does it seem to really wildly vary over short periods of time? Or is it more that it seemed to be fast a few months ago, but it's just progressively for the same values kind of gotten slower and slower and slower over time? So that's kind of one thing that I'm going to look at is what do they mean by execution times vary? I also want to know, is anybody looking at the plans? Is anybody able to get some insight into how that query plan may have changed, or how different that query plan is? And again, is it different that it's been different over time, or is it different between 1 a.m. and 1 p.m.? So I need to know a little bit more about that. Then I want to know about I/O, CPU. I want to know what's actually going on in terms of the executions of those queries. Now, the variations are often due to the statement execution method. That's what I'm going to focus on mostly in this session. What is the statement execution method? How are they executing and interacting with SQL Server? Is it ad hoc? Does the client application submit literally just strings of SQL that are built on the client and then just submitted to the server? Or does the client use some type of forced caching method where they're using parameter placeholders? Maybe they're using SP Execute SQL. Maybe they're using some other method of forcing the caching from the client. So we need to get some insight into that. I also want to know if it is parameterized, if it's built into a string, or if it's actually got placeholders, and if those placeholders, like I said, are some forced caching method, or maybe they're a stored procedure, so we're going to look at that. And as I've already mentioned, the time frame over which those variations have occurred. So these are the things I want to start getting some insight into, like the behavior of these statements. Now, the response is equally important, and even how these responses are working or not working for you. There's often what I call sledgehammer approaches to these performance problems. Like sometimes people will say, oh, the performance is poor, and when we update our statistics, we get better performance. Well, okay, is it the stats, or is it the actual secondary side effect of updating the stats that's helping you? Because when you update stats, SQL has to build a work table in TempDB, it has to read the data, or at least sample the data, it has to build a histogram, and it has to calculate what your data looks like statistically. But the last thing that updating statistics generally does is it invalidates the plan from cache, so the next execution will get recompiled. And if that works, then what might have actually solved your problem was the invalidation of the plan, not the statistics having been updated. Now, don't get me wrong, statistics aren't perfect. There are lots of things that you can do to help statistics. I'm going to talk about those in the second session. But it's really important to figure out what the root cause of the problem is, because updating stats might appear to work, but you're doing a tremendous amount of work by updating all those statistics when in fact all you may have had to do was invalidate the plan and you would have gotten the same result. Now, don't get me wrong, clearing the cache is not a great way of solving these problems either. But what's really interesting is sometimes clearing just that plan from cache, running it again and seeing if that solves your problem. And then if it does, you know that it's actually a caching problem and not, in fact, a statistics problem. So that's what we really have to figure out first. Now, rebuilding indexes, another sledgehammer approach, is even worse, because what you're doing there is you're looking at all the data, you're rebuilding the indexes, you're updating the stats as well. So you're really compounding the problem. And here you're invalidating the stats as well at the end of the process. So again, you might get this false positive, but it's really a terrible approach. And like I said, clearing the cache certainly could help if you're clearing just that statement or just that plan from the cache. But if you're clearing the entire server cache, then you're really not helping at all. So these are all sledgehammer approaches that I want you to avoid as much as possible. But if you've done these things in the past and they've appeared to work, then I would probably argue you might have, and probably do have, caching problems. So now, when I talk about troubleshooting some type of query's performance, there's a couple of things that I first like to ask is, how is that statement being executed? If that statement is a stored procedure or it's being executed through Execute SQL, I immediately know that these are caching methods, because most databases are set for what we call simple parameterization by default. Now, I'm going to come back to this, and it is incredibly rare that I ever recommend forced parameterization. So I want to start by saying simple parameterization is very likely to be what you're running, and if you're not, I would really argue that you may want to go back to simple parameterization and do some testing in your environment to really make sure that forced parameterization is a good idea for you. So, but let's wait till we come back to that slide. So first, if it is a stored procedure or Execute SQL statement, then there's a few things that I can do to test. I can actually take that stored procedure and execute that stored procedure in Management Studio with the parameters normally, and then have a second line which executes that procedure with those same parameters, but then uses the clause with recompile. Now, execute with recompile is not something I would generally use in production. The statements don't go to the DMVs for DMExec query stats. The procedure doesn't go to DMExec procedure stats. It's really not a great way of troubleshooting long-term in production. So I don't use execute with recompile in production, except for testing. So if I can, in Management Studio, reproduce the behavior and execute with recompile and see those two plans next to each other, and I can see that those plans are different, right? Not even knowing all of the details of what the plan is, but just that, in fact, the plans are different, then I immediately know that the plan in cache, which is what you get when you execute the procedure with just the parameters, versus execute with recompile, which gets a plan just for that execution. It doesn't touch the plan in cache. It doesn't clear the plan from cache. It literally just puts that execution, right, runs it and doesn't touch anything else about that procedure. So this is a great way for you to just kind of do a one-off test. Is the plan in cache different from the plan that I get when I execute just for me? And if the answer is yes, then what you know is that the optimal plan, which is what you're getting when you execute with recompile, varies from what the current plan is in cache. Now, execute with recompile, again, has all sorts of negatives to it. It doesn't even do the most effective method of recompilation. Option recompile at the statement level is much better, but that requires you to modify the procedure. That's more work. You'd have to create like a copy of the procedure as a test copy, have one that executes with the plan, one that, gets a new plan with option recompile. You could do that, but all I'm trying to do at this point is just quickly see if the plan in cache is different from what I get when I get an optimal plan. And if the answer is yes, then I know I have a caching problem. Now, if this was executed with Execute SQL, you can simulate that as well if you can generate that same Execute SQL line and put option recompile into it and compare those side by side. That's a little bit harder, but I would almost argue at this point, if you are getting variations in the executions of this statement executed with Execute SQL or this procedure that has parameters, then I already know that you very likely have a caching problem that we generally refer to as parameter sniffing or parameter sensitivity. And if it's a stored procedure, which is generally my preference, I can change that code and get a lot better performance by looking at the different executions and coming up with cached plans for when the plans are stable and recompile the plans when the plans need to vary. And I do this programmatically in my code. I have some free sessions on Pass. I also have some recorded sessions on Pluralsight. I can get you guys a code if you don't have access to Pluralsight. But the point is, there's a lot of content out there that can help you write better procedures. But here I want to talk about caching. So I want to come back to this. So the first thing, is it a poorly performing but new statement? So now I'm saying, okay, it's actually not cached. What if it's the very first time you've ever executed, or you just cleared the cache and reran it again and the performance is terrible? And you even try to recompile it, which, you don't even need to do that. If you just restarted SQL Server, you just cleared the cache. But the point is, you're positive that you've done everything to ensure that this statement is not a cache plan and it's still terrible. Well, then I would start looking at things like estimates versus actual. I would see how far off that estimate is from actual, and I would start looking into whether or not this is actually a statistics problem. So that's what I'm going to cover in part 2, is you've gone beyond the fact that it's not cached. It's not a caching problem. You're pretty sure it's a statistics problem. So then what can we do? We can update stats. We can update stats with full scan. We could do something like filtered statistics. Or in some cases, the statistics are really as good as they can get, and we just don't have the right indexes to support the types of queries that we're running. So indexes might be the better solution, but we have to be able to troubleshoot properly so that we don't do the expensive things like rebuilding indexes or creating indexes when those are really not our first choice. They're just too expensive in general for us to abuse them. So I really want to get at the root cause of the problem first. So that's why we're going to spend the rest of this session talking about caching. So what happens when you execute a statement, right? Does it go into cache? Does it get parameterized? Right? What happens with that statement? Now, there's different ways to execute. There isn't, unfortunately, one way that's always best either. And I hate to say this because I know developers want to have, the best way to interact with SQL Server. But sometimes certain types of statements are best when they are ad hoc. Whereas other statements, since maybe they have a nice, consistent plan, they should be cached and they should be executed maybe a different way through a stored procedure, or if we're not using stored procedures, maybe SP Execute SQL. But we have to know a little bit more about the statement and the characteristics of the statement to really do this correctly. So that's what we're going to talk about. Different ways, the different reuse methods, the caching that occurs, and then what are some of the side effects of caching all of our ad hoc statements, for example. So as far as the different ways to execute SQL statements, you can execute ad hoc. So let me define what that really means. Like if you're sitting in Management Studio and you type in a query, then send that off to SQL Server. That is what we would call an ad hoc statement. Now, you could also, like in the client, build a statement dynamically, putting all the pieces together, and then pass that in as a parameter to the exec statement and send that over to SQL Server. And that is exactly the same thing. In fact, I would say these two, ad hoc statements and dynamically constructed strings that you send over to SQL Server as an exec statement, those really work the same way, behave the same way, do the same thing. They can even be, whether it's an ad hoc statement or an exec statement, they can even be parameterized and cached. A lot of people think that exec always recompiles. That's actually that's not correct. It's a misnomer. Exec creates an ad hoc statement. Now, a lot of ad hoc statements cannot be cached, so they do get recompiled on every execution, but we'll talk about what happens with ad hoc in a second to really clarify this. Now, everything else on this slide, SP Execute SQL, prepared queries, stored procedures, these are all other ways to execute, but these are what we call forced caching methods. Now, SP Execute SQL is one that a lot of you use. I love SP Execute SQL. I think it's a great way to interact with SQL Server when you have a statement that you want to build, and that statement's plan is very consistent on each execution. Now, some clients will allow you to use parameter markers and help you build stored procedure like cached statements. Those work exactly the same way as SP Execute SQL, and in fact, they work the same way as stored procedures. So what actually happens with any of these statements that are cached is that SQL Server first looks to see if there's a plan in the cache already that's suitable for that execution. They then will reuse that plan. But if there isn't a plan in cache that's suitable for that execution, then they will create a plan based on those parameters that have been passed in. That plan will then go into the cache and be reused on subsequent executions if the conditions are right. And I know I'm being a little bit vague on that one, but caching is actually quite complex. You can have multiple plans in the cache for the same stored procedure for different users if the client's session settings are different, or even if the resource governor group is different. So this is where things get a little bit tough to troubleshoot, is that when I say you will reuse a plan, you're only going to reuse a plan that's suitable for your session settings and your resource governor group. So if everybody's using the same application and the same application settings, and you're not changing those session settings with things like ODBC settings, client settings, then you might be very consistent. But unfortunately, if the session settings are getting changed, then you could have multiple plans in cache, multiple different plans in cache, even for the same stored procedure, even for the same application, because the clients have changed those session settings. So it is really important to get some insight into how caching works and how troubleshooting cache can really help. And I have done some troubleshooting cache code in my Optimizing Stored Procedures session part 2 on Pluralsight, if that's interesting to you, where you can actually see the session settings and so forth. But it is something that you're going to have to be able to figure out. So this gets a little bit difficult, but the first thing that I want to talk about is kind of what happens and how those plans get into cache. Now, before I can even go that far, I like to talk a little bit about how we got here. Like, why do so many of you have this problem? Now, these behave the same way, the ad hoc statements and the dynamic strings, and these behave the same way. But the question is, what is your application doing, right? So how did we get here? Why are so many of you having so many of these issues? And I do have to blame some of this on ORMs. ORMs are object relational mapping applications, and they're known for their wonderfully rapid application development. And they can, get that application out there so we can see if that application works and so forth. But the problem is you might get fast to production, but you might be incredibly slow when you're in production with these ORMs. And you have to be a little bit careful with how you've structured your application, because a lot of these ORMs are generating ad hoc SQL, and a lot of ad hoc SQL. And some of these ORMs were led to believe that this was an okay thing because they were told that SQL would cache and that SQL would take their statements and even parameterize those statements and put them into cache. And I remember one Twitter thread that I read, and I brought this up on the slide. I don't know this person, Katie McCaffrey, although I probably should find her and talk to her, but she started a thread on the pitfalls to ORMs and pointed to actually Adrian Coyler's article, and maybe I need to meet Adrian as well. But the point is, she talks about how this paper sums up some of her feelings on how it's difficult for an application to really pull together that statement dynamically and then execute that efficiently. And it kind of continues from here, that ORMs can often be poor abstractions of your environment. What they're trying to do is take, that relational environment, map it to the T-SQL, and just generate the SQL for you so that you don't have to write any code. And they often end up with kind of a very simple, very lowest common denominator kind of format. And unfortunately, they don't take advantage of a lot of special features in SQL Server. So there's going to be a lot of negatives just even in the kind of bland and often just ANSI standard SQL that they generate. Now, it's not just that though, right? Even if it is, ANSI standard and SQL Server can optimize that. The problem that we have is that you're really sending a lot of ad hoc statements. So those ORMs were led to believe that that's okay because SQL Server auto-parameterizes those statements. Now, the definition of auto-parameterization, because I really agree with this becoming a big problem. The big problem is that not really everything gets cached as effectively as the ORMs were led to believe. So I like to think of it this way. Yes, some ad hoc statements and some dynamic strings can be cached. What does that really mean? Well, the definition is kind of coming back to this concept of simple parameterization. And SQL Server will parameterize those statements which are simple and could lead to a nice, consistent plan. And it is a good thing that SQL Server does this, right? Because if they can take that statement and parameterize it, they're going to save time in terms of CPU. They're going to save query time, right? In terms of having to compile. And then if they've got this nice, consistent, good plan and cache, then we execute a plan and we run from there. Now, if you look at some of the statements on this slide, select, and then some query columns and so forth from a table. So I'm basically saying that ... for these three statements is the same across all three of these. So select something where member equals 12. Select same stuff from the same table where member equals 278. Select same stuff from the table where member equals 675, right? Or 62,000. So my point though is all three of those statements are very simple. They're going to return only one row in this case. Let's say that's the clustered key we're selecting from the member table. So SQL Server is going to look at that statement and say, this is really simple. This is what we call safe. They've got a definition. So they say, yes, this statement is safe. So we're going to auto-parameterize it. We're going to put it into the cache and we're going to reuse it. Now there is one negative here, and I'm showing that on the slide. Each time we execute, we're going to determine, SQL Server is going to determine the data type of that literal and actually put a plan and cache for that data type. So you get a little bit of what we call prepared plan cache bloat. You'll get one for each of those different data types. But the point is that as you execute hundreds and thousands of these statements across only, let's say, 2 or 3 different data types, then you're going to execute those 2 or 3. And since this statement is very simple, it's really just one plan with 3 copies for each of these data types. Okay, so that all sounds great. So simple parameterization and the fact that SQL Server will parameterize these statements for you sounds like a great thing. And then you start reading the fine print. There are some white papers on this, or you even start to look at your server and you start to wonder why you're eating up a lot more of your cache than you thought you would with what we call prepared plan cache bloat or plan cache bloat. So what ends up happening is most statements actually won't be simple enough to be safe. So this is the definition of simple parameterization. And one of the rules, it's right on this slide, is that the from clause cannot have more than one table. I remember the first time I read that, and I have to tell you, I just kind of went, what? This is one of the rules for parameterization? Because if this is one of the rules, then I'm out. Like most of my statements reference more than one table. And I have to admit, it gets even worse than that, right? It's you can't have an or, you can't have an in clause, you can't even have variations in the where clause conditions themselves that would return varying amounts of data. Like if I say select from blah, 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 where last name equals Tripp, whereas I say select blah, 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 where last name equals Anderson, well, Tripp might be highly selective, but Anderson isn't. SQL Server will detect that variation with that column and actually even say, even though this statement is consistent in its format, in its structure, and even just supplying one last name, the data varies so much that this statement isn't safe either. So what ends up happening is most ad hoc environments built with ORMs that were convinced, in some cases, that SQL would auto-parameterize and make everything work like stored procedures, end up not doing that. They end up bloating the cache with the same statement, sometimes over and over and over and over again in the cache, sometimes with even the same plan, but it just wasn't simple enough to get auto-parameterized. So it wasn't deemed as safe. Now, in an environment where all of the statements are simple, they have one plan, but aren't safe, you could switch to forced. But it's really uncommon that one statement that has a bunch of different values always returns the same plan. And if you're convinced that your environment is incredibly tuned for this, then there are ways that you could go and analyze your environment to see if you should go with forced before you set it to forced. This is really important. If you are in simple and you look at the cache and you see all the executions in the cache, they will end up having the same query hash. You can also check the cache, and I'm talking about dmexec query stats. So you can check dmexec query stats, aggregate by query hash, and see how many query plan hashes a query hash has. And if one query hash has thousands of executions, but has only one query plan, and then you have another query hash, and it has, dozens of executions, and they only have one plan, and you check through all of the different query hashes, and all those query hashes have only one query plan hash, then you have a pretty straightforward environment that has a consistent enough workload that you could force SQL Server to put those plans in cache, but they're not simple enough for simple parameterization to do it. So I really want to stress that it's very uncommon for most of you, and it's really important for you to check before you turn on forced parameterization. And it's pretty rare that I turn this on, but there are some environments where when they have a very, very finite workload and a very well-tuned workload and a very predictable workload. I mean, come on, how many of you have that? But there are some environments that have this. And when that's the case, then forced parameterization is great. But most of the time, simple is best, okay? So I really, really want to stress this. Like this alone, the from clause cannot have more than one table. I mean, come on, most of you have to be thinking, okay, that's it for me. I'm pretty much out. And this is true. Most of you will not get most of your statements to be parameterized. So they will end up going into cache. As I said, by default, right, parameterization is simple. Most statements will not be deemed as safe. And I want you to keep things simple. I want you to keep your database option to be simple. I don't recommend forced parameterization, but like I said, you can go before changing it to forced and go and check out your query hash and your query plan hashes and see if you in fact have an environment that even though SQL Server is not forcing your statements into cache, you might be able to benefit from doing so. So again, very uncommon, I think, across all of SQL skills over the numerous years that we've had these database options. We've only turned this on in like 3 or 4 databases. So really, really uncommon, but definitely something for some of you to be aware of. So that is simple versus force. Now, what I want most of you to do is keep your environment in simple parameterization. Now, with simple parameterization, what that means is that every ad hoc or every dynamically constructed string, these are not built or known until runtime. So what ends up happening is you can put placeholders in, you can build that statement dynamically, send that off to SQL Server, and then SQL Server starts to evaluate it. They actually parameterize pretty much every statement, but then they get to what I call this fork in the road, and they decide, is this simple or is this not simple? And if it's simple, then that parameterized statement goes into the cache with its plan. But since most things are not, I should have said safe, right? So if it's safe, then it goes into cache, right? But if it's not, then each time it executes because it's not safe, it gets recompiled. So this is why a lot of people think exec always recompiles. And it's really not that exec always recompiles. It's that most of their statements are probably not safe, so they get this appearance that it's recompiling every time because it's not getting parameterized and saved, okay? I like dynamically constructed strings. I like exec from an administrative perspective. I use it quite often, but you do have to be careful from a security perspective. I've got some blog posts on SQL injection and reducing SQL injection if you are going to use exec. I do often use Execute SQL in my stored procedures because sometimes what I end up doing is I dynamically build my statement, and at the very end, I kind of determine, is this pattern one that needs to recompile or not? So if it needs to recompile, I usually have a little flag in my code. I tack on option recompile to the statement, and then I execute it with Execute SQL. And I've got some blog posts out there, and they're in the resources, but building high performance procedures, that's one of my blog posts, talks about kind of dealing with your stored procedures code and kind of saying, if my parameters warrant the same cached plan, then I will Execute SQL, that combination of parameters, and Execute SQL will force it to go into the cache. But if I have a combination of parameters that should be recompiled, I have this little flag that then tacks on option recompile, so statement level recompilation, tacks that on and executes then with option recompile that statement within that stored procedure. So I end up getting this hybrid where I cache my plans with Execute SQL when they should be cached, and I run them with option recompile when they should be recompiled. So I actually build my strings more dynamically, but then I execute them usually in stored procedures with Execute SQL using option recompile where I need to cache them. Give me a second here. Okay, so I'm not going to get into the whole security discussion around ad hoc statements, but I've definitely got some blog posts that you can read. I do like exec, okay, but realize that there is a huge difference between exec and Execute SQL. Exec builds the statement as a dynamic string, essentially, and then sends it over as an ad hoc statement. Okay, so then it might be cached. If you send it with Execute SQL, you are forcing that statement to go into the cache unless you put option recompile on it. But if you put option recompile on it every time, then that's not what I'm trying to do here. I'm trying to have a balance and only use option recompile selectively, conditionally, and not even as frequently, if I can avoid it, as the cached versions. So that's a really important thing that I talk about in building properly optimized stored procedures. But we have to know how these statements work first before we put them into stored procedures, because that creates a lot of problems. If you put all these dynamic strings into exec, you're kind of defeating the purpose. It's like putting option recompile on the statement every time, because most of the statements won't be safe, they won't be parameterized, and they'll get recompiled. You might as well have just built the statement and used option recompile. I think that would have been a better choice. But the best choice is to figure out like a little bit about the patterns of execution and really have a better balance between recompiling every time or caching a plan that maybe isn't as optimal. And this is the thing I want to stress about stored procedures, about SP Execute SQL. If you build a statement and then you execute it with SP Execute SQL, you are putting that statement into the cache, and subsequent executions with that same statement pattern will reuse that plan. Is that a good thing? If every combination of those parameters yields the same plan, yes, it's fantastic. But if the different parameters really warrant, or if there's a certain combination, I like to talk about like a specific combination of things. Like if you are supplying 3 parameters, let's say member number, you know what? I am going to go over to a demo screen and I am going to show you this for a second. So I have a ton of scripts for you. You can see this here. In fact, right? The nice thing that I've done is I've created a couple of different projects within this solution. I've got, optimized for unknown, plan stability expressions, testing, just a ton of stuff that I want you guys to play around with. And there's a lot of notes and comments in here. This script right here is the dynamic string execution one. But let me just bring up a new window for a second. And let me just give you a concept, right? Let's say that you have 3 parameters, member number, last name, and first name. And when you execute, you could really supply any combination of them, member number and first name, member number, and I have to look at my keyboard because I wasn't planning on typing, which of course, as we all know, is the worst thing I could do in a demo. But of course, I'm going to do it anyway because I just want to make this point. And luckily there's not that much typing in this, first name and last name. Okay, so if I've got 3 parameters, member number, last name, and first name, then I can essentially execute them in 7 different combinations. So imagine that these were passed into a stored procedure, and that stored procedure then built the statement dynamically, but only with the non-null values of member number, first name, and last name. And at the very end, it decided, do I send this to SP Execute SQL and let it go to cache, or do I recompile? Now, think about this for a second. If you send select from member where member number equals and first name equals and last name equals, right? But you allow these to also be null. So member number equals or member number is null. First name equals or first name is null, right? So you're trying to create this kind of generic pattern for these different parameters. The cool thing is, if you supply member number alone, right? Think about that for a second. That's always going to return 1 row. That's always going to have 1 plan. It's going to be very simple. Whereas first name and last name, the question that I have to ask is, are you going to allow wildcards? Are you only going to allow equality? How wildly varying are these values, right? If it's member, email, last name, first name, well, you might end up finding that member number and email are unique, and they always return 1 row. So it might actually be that even though there's 3 parameters or 4 parameters or 5 parameters, when they execute certain parameters like member number, right, then you know that this can actually use a cached plan and doesn't need to recompile. But when they start putting last names and first names, because you put like in your conditions, those should recompile. So you could build this statement dynamically, and at the end you could do something like, if the member number is not null, then we're going to compile and put that plan in cache. Otherwise, recompile. And this is what I talk a lot more about in my blog post. And I've actually got the scripts over here. You can see set up for multi-purpose procs, multi-purpose procedure, and some different solutions. And this multi-purpose procedure is a really good one to kind of look at because it kind of highlights this ugly code that sometimes you guys would have with a whole bunch of parameters and a where clause that looks like this. The cool thing, you could just go ahead and put into your code, like I have here, option recompile. And that would make it recompile every time. But the problem is, for the case where they supply member number or email, you're going to be recompiling where you don't really need to. So the better solution, and it's really ugly, don't get me wrong, right, is to build it more dynamically and then conditionally, right? Look for certain criteria. If they supply at least a few characters of the last name and they supply a few characters of the first name, then we don't need to recompile even with our like. Because if they say where the last name is TRI and the first name is, KIM%, then we're okay. So we've got a few things here, like if member number is not null, we don't need to recompile. If they supply at least a few characters, if they supply at least 10 or 12 characters of the email, or maybe we require the whole email, then we can say not to recompile. But the point is, you can now do this conditionally and then send off to SP Execute SQL the code where some get recompiled and the others get cached. And this is the beauty of knowing how SP Execute SQL works. You are kind of creating, based on the data patterns and your knowledge of the environment as a database developer, the right balance to the way that that code executes on the server. So let me go back to the slides and really kind of make more sense of this. But the point is, right, if you understand SP Execute SQL, then you can combine that into your stored procedures very effectively so that you can cache certain patterns that really are nice and stable and really warrant that plan to stay in cache. So I love SP Execute SQL, okay? I think it is something that all of you should be considering and should be using, but unfortunately, if you never put option recompile in it, then you could have the same problem with SP Execute SQL that you may have been having with the stored procedure before you built the statement dynamically and stuffed it into SP Execute SQL. The only difference is that the stored procedure has essentially one plan, whereas then when you put something into SP Execute SQL, you'd have one plan for each version of the statement, right? So like if you were only doing the not null parameters and you had 3 parameters, then you'd have 7 combinations. So there would be 7 statements in the cache, but they'd all be forced caching, right? So at least you're going from 1 plan to 7. So that in and of itself is sometimes good, but probably in some cases where those parameters yield wildly different results, maybe a couple of those combinations should also be recompiled. And that's the beauty of not building the statements dynamically, not building everything in the client with an ORM, right? That's the beauty of having the stored procedures on the server written and managed by developers that kind of understand the data and understand how SQL Server works and understand caching. And it's not entirely intuitive, I have to tell you. So this is why I think a lot of people get frustrated with SQL Server and say stored procedures stink. But they don't, right? It's just understanding how they work. So this is really important. So stored procedures work just like SP Execute SQL. They place a plan in cache for the stored procedure, whereas SP Execute SQL is placing a plan in cache for each of those kind of versions of the statement that are being executed by SP Execute SQL. And reusing plans is fantastic. In fact, SP Execute SQL is the best way to execute a stable statement, for sure. Where it's problematic, just as problematic as your stored procedures, are when you put into cache a plan that really doesn't work well across a whole bunch of executions. So you really want to be careful, especially with stored procedures, because you essentially have that one plan for the stored procedure for all the different executions. But even if you start putting things into SP Execute SQL, there still may be times where you want certain patterns to recompile. But I really like to do it selectively and conditionally in my code So this is why I'm such a big fan of stored procedures that are centrally located on your servers, managed by DBAs that know SQL Server, that know how the environment works and can create more optimal procedures and more optimal code. So now let's bring back together all this caching stuff, because there's a little bit more that I want to stress on the life of a plan in cache and what some of you might have to also deal with if you still have ORMs and you want to kind of get a better balance with the ORMs. Now, a plan is generated when there isn't a suitable plan in cache. And I kind of explained that suitable stuff a little while ago. So if there isn't a plan that's valid for my session settings and my environment in the cache, then a plan will get generated. SQL Server never saves plans to disk. They never have, right? They're always in cache. The only thing that's saved on disk is essentially the code. And when you run, they check for a plan. If there isn't a plan, they generate a plan with those parameters, and then subsequent executions reuse those plans. And there's a bunch of things that could cause those plans to get pushed out of cache. I have some hidden slides in this deck as well that explain a little bit more of kind of the weird history of plan invalidation. But I just want to stress that they're not permanent in any way. But once they go into cache, they might get reused, like for a stored procedure, for an SP execute SQL statement, right? But for ad hoc, you might get that plan in cache for Tripp, you get that plan in cache for Randal, you get that plan in cache for Kahayas, you get that plan in cache for Green. So you get all these different plans in cache for the same statement, and you're bloating and bloating and bloating the cache. So we need to know how to deal with this, because you can end up wasting a lot of cache. It was really bad in earlier versions of SQL Server, like SQL 2000 and 2005 were the worst. I'm just going to kind of cut to the chase now in later versions. And it's basically been like this since 2005 SP2, that there's a certain percentage of the cache that can go to all of these cached plans. Now, if the cached plans are in fact good, stable plans that are getting reused and reused and reused and reused, then this is great. But unfortunately, if your plan cache is getting bloated with ad hoc statements, then this is where you're possibly wasting cache. And the biggest problem that I tend to see is for those of you that may have consolidated. If you've consolidated and you have a smaller amount of memory, like only 32 gig, right? You could end up, if you look at this, you could end up having about 5 to 6 of that gig being used for your plan cache, which if it's all getting reused, that's fantastic. But if that 5 or 6 gig of your only 32 gig, which of course you don't even have all of that necessarily for SQL Server, but if you are wasting that much of your memory, the problem is if they're all ad hoc, then there's no point. You might as well just be clearing the cache a little bit more frequently. Now, how would I do this? I would not just clear the cache all the time. Okay, that's not what I'm saying here. But I would, and I sometimes do, and I've got some recommendations and some code for this, where I actually look at the cache periodically, and I will go ahead and clear a certain amount and a certain type of the cache. So let me kind of explain this, okay? So as far as the cache itself, I would look at the cache and see if you have something called plan cache bloat. And I have some plan cache slides in here that you guys can see this in the samples and the blog posts in my resources section. So that'll show you where the code is. And this will show you essentially how much of your cache has been used by what we call single use executions. So if you have a lot of statements that have only been executed once, then what will end up happening is you're going to be wasting a lot of your cache. I would first turn on the option called Optimize for Ad Hoc Workloads. And some of you are probably wondering why I hadn't even mentioned that until now. Yes, this is pretty much on in every environment I work with. However, it has its own negatives if you just turn that on and you're on a 2 terabyte of cache environment, then the amount of memory that you can end up using for this is huge. So I would not just turn this on. I actually do 2 things. I turn this on and I regularly check my cache to see if I have a lot of cache that is being used by single-use plans, because that means that I then am wasting my cache with plans that have only been executed once. And if that's the case, then if I have a certain percentage of my memory that's being wasted, like let's say I do have, 6 gig of memory, and I then have 5 of that 6 gig that's single-use plans, then what I might do is just clear my plan cache that is ad hoc or prepared. The coolest thing about DBCC free system cache, and I have the code, the wrapper that kind of analyzes your cache and then uses DBCC free system cache. The cool thing about free system cache is it only clears the ad hoc and prepared plans. It doesn't clear things like stored procedures from the cache. So this could be a really great solution for some of you that have a lot of ad hoc statements occurring, but also have a bunch of stored procedures, because then if you have a lot of plan cache bloat from the ad hoc stuff, you can essentially throttle it. So instead of wasting, whatever that limit is, you waste a certain amount and then cut it back, and waste a certain amount and cut it back. And the amount of data cache then can be increased, because that's kind of a sliding window there. SQL Server has a certain amount of memory and a certain amount that it can use for plan cache. And if you make that smaller, if you use less of that for plan cache, then you could use more for data cache. So you won't be wasting those resources with statements that are only executing once. So this is really the 2 steps that I always do. And then, of course, I go back and I start to look at the way that I interact with SQL Server. And I might end up switching some statements to SP Execute SQL if I can change the code. If I can't change the code, then you might consider using forced plans, because you can force. There's really multiple ways to force statements. You can force SQL statements. You can force objects. You can force like a stored procedure. But I would go ahead and take something that was simple and not deemed as safe and force it. And I can do that if I can't change the code. So it's a little bit of micromanagement. It's a little bit of work. But that's another option that you could go through if you really wanted to force some of those statements. So what I really would stress, though, is to try to move towards, if it's an application that you want to live for a long time, if you want that application to be more optimal, I would really, really want you to move towards stored procedures, right? I want you to have that centralized logic. I want you to have database developers that know how SQL Server works, that know a little bit about the data, and can have a better environment where you do end up having recompiled code that is nice and safe and stable. Or I should say compiled code that's nice and safe and stable, and recompile where you need to. So you get this better balance of CPU and performance. So I love this topic. I see this topic or this problem everywhere I go. And I see a lot of misunderstandings. Again, developers aren't stupid. They just don't know that there's so many variations in this. SQL Server is a huge product that has a lot of different options, a lot of complexities, and a lot of flexibility as well. If we don't know that these things exist, it's very hard to do things right. But once you know how these things work, you can really have a much, much more optimal environment with SQL Server. So as far as resources, make sure you look at these. I do have a bunch more on Pluralsight in terms of, optimizing ad hoc statement performance, optimizing stored procedures. I have a bunch of resources in terms of white papers listed in my resources at the end of the slide deck. I also have some plan cache pollution resources. This is where I have the queries that will show you how much of your cache is being wasted by single-use plan cache and plan cache bloat, as well as the code to help you analyze how much of your cache is being wasted. And you can then programmatically say, if a certain amount is being wasted, then I want to use DBCC free system cache to clear that plan cache bloat from my cache. So I've got all of this here. And then I also have a building high performance procedures blog post, as well as a PASS session that you guys can get off the PASS site. So there's just a ton of resources out there. And I hope you guys have enjoyed this today. I am online and answering your questions, hopefully already. And I will stick around for some more questions. And I will hopefully see many of you tomorrow in part 2, where you have decided it's not a caching problem. And in fact, it is a statistics problem. So what the heck do we do with those? So thanks, everybody. I really appreciate it.